Hey, so this is the part two. I set up the file so it's working a little bit better now. Um, so again, in this example, we had narrowed our options down to this mountain event or this hotel event. And we'd started with, say, 5 or 6 different alternatives. We did our plus minus table. We found some dominance. We eliminated some alternatives. And the top two options, accounting for all the different types of ways of looking at this, were to have this event on the mountain or to have this event at the hotel. And there's this event was happening in a hotel ballroom. And let's take a look at what our 1 to 10 table looks like. So I have it in here. And so as we can see here, we're just down to these two options. We've weighted expense 30%, so that's our cost, amount of fun we're having, and our memories. Don't have written down here how we're measuring any of this stuff. This is just for an example. So here's our 1 to 10 table, and as we can see here, the mountain is coming up on top a little bit. When we're doing our sensitivity analysis, though, and we've found that, my goodness, the amount of fun here that we're having is really depends. I mean, we're not sure how much fun we're going to have in these two different alternatives. And so, what are we unsure about? What is the worst that could happen? Well, what is the worst that could happen on a mountain? And let's just say it's November on a mountain, and well, what happens usually in November on a mountain? Let's just say we're in Colorado. Um, well, it snows or it rains, right? So you could have a ton of rain at this outdoor event, and well, that's going to change our picture a little bit, wouldn't it? So what do? What's the first thing you want to do to figure out what could possibly happen here? You want to be asking yourself the question, well, what is the what is percent chance of rain in November? Because based on the rain, your 1 to 10 table is going to look a ton different. I apologize for the horking. That's our small dog who likes to walk by and hork. So that's what she does. So again, so figuring out the percent chance of rain in November on a random day, we took a look at that and we're able to come up with the following: is that there's a 75% chance that it's going to be sunny on the mountain. Um, in this example, that this mountain is not in Oregon again; it's in Colorado. And there's going to be a 25% chance it's going to rain. So how do we start modeling this in a way that makes a little bit more sense? So let's start taking a look here. And don't worry about any of this stuff for now. But as you can see, we're populated our 1 to 10 table again, but accounting for whether it's sunny or rainy in these different scenarios. So here we have a 75% chance of sun. So when it's sunny, our expense is going to be a 7. When it's rainy, it's going to cost us a little bit more to be up in the mountain because now we're going to have to pay for umbrellas and all that type of stuff. If it's sunny, for sure we're going to have a lot of fun. If it's rainy, it's going to suck. It's not going to be as fun. Memories, plenty of great memories when it's sunny. When it's rainy, memories you maybe not going to want to look back on. So for the hotel, it's going to be just about as expensive either way, not so bad. Less expensive if it's sunny, a little bit, actually less expensive if it's rainy, everybody's inside, a little bit more expensive because you get to use this outdoor patio up here. Plenty of fun either way, and the memories are the same. So now we've modeled what the effect of this uncertain event happens, how this impacts our 1 to 10 table. So similar to this other example we had, where now we're going to be calculating our expected value. So our expected value in this scenario, where we're on the mountain and it's sunny, our expected value here is 9.1. That's great. So we're on a scale of 10 again. That's looking awesome. And again, we've got our complicated looking formula up here. I'll provide you this spreadsheet so that you'll be taking your first two options and modeling some uncertainty into it just to see what happens. You'll be doing this in the worksheet due this week. So in our rainy example, we've now got an expected value of 4.2, which is terrible. And when we take a look at the hotel, when it's sunny, 7.1, when it's rainy, 7.4. So this is kind of in the middle. So what do we need to do now? Well, we can't just add up these two values together, our 9.1 and 4.2, and get a nice EV, because that does not take into account the probability right here. So what we actually need to do here is take the actual probability, 75% chance of sun, times our total EV. So we have 75% chance of getting this 9.1 value. So that's where we're getting the 6.825. It's basically 6.8. We're just taking our EV, multiplying it by the percent probability, and we arrive at this value, which we can then add up to our next value. So same thing over here, 25% chance of rain, multiplied by our EV of 4.2, and that's 1.05 over here. And we're doing the same thing down here, 75% times 7.1, we're at 5.3, 25% times 7.4, we're at 1.85 or 9. And then what we could do now is we can have this all nicely added up, where we have our option here is making a little bit more sense, where we're taking our 6.825 plus 1.05. Now we're accounting for the total effect of the weather, and say, accounting for the probability of the weather, we have this uncertain event of the weather, this is still a better option. We're at 7.8 or 7.875. This is a little bit better than the safe route, which is still 7.175. And so according to our analysis here, we would say we're going to go with the mountain. Yeah, there's a chance that it could be terrible, but it's worth the risk. That's if we've modeled this correctly. The other nice thing about this is that you can take this information and, again, share the decision with other people. You say, this is how we're modeling this decision. This is how we're justifying making this choice, such that, let's say, 2 weeks later you're having this event, and my goodness, that 25% chance of rain happened. At the time, this is all the information you knew, and you would have made this choice again if you could have. Based on what the expected value was, because there was still that 75% chance that you could have had a great time, but it just didn't work out that way. If you're able to think that way and communicate that way, you're lessening the odds of any regret taking place. So that's how this example looks. You'll be doing similar with your own decision in this worksheet. So good luck with that, and in class, let me know if you get any questions with how this works. I hope it was clear.